Halo Ukrida, saat ini saya sedang berada di auditorium lantai 7 Gedung E Kampus 1 Ukrida. Sesaat lagi kita akan menyaksikan expert sharing ke-7. Selamat menyaksikan.
And then you type an open curly set bracket, hit the return a few times, and type a closed curly set bracket. Every object has to have these set brackets surrounding the properties of the object. The property of the sphere is its center. We are going to place the center right in the middle of the screen. And every object's location is described in terms of three numbers in angled brackets. So let me put angle bracket 0, 0, 0. The zeros simply tell how it's right smack. So what I've said here is we're going to draw a ball, a sphere. The center is going to be 0 up, 0 up or down, and 0 in or out. So the first two numbers are left and right, and the third number is in and out. I'll show you what those mean precisely in a moment. But for now, let's see what happens when we click on save before render. File untitled has been changed. Automatically click on this little box here. Automatically auto-save files for the rest of this session. Then click on save, and we have to give it a name. So let's call it S1. Press 1 for lesson 1, and then click on save, and it draws us a black window. Well, we'll close that window, and the reason we're getting the black window is we haven't given the sphere a color. So what we can do is we can give it a pigment. That's pigment, and again, open set brackets. We'll call it red, and then close the set brackets. And let's see what this does. Okay, when it highlights something in yellow, it tells you there's something that is wrong, some kind of error. If you look at the bottom of the screen, it says parse error, no matching something or other in pigment. I don't understand that. It says undeclared identifier. Okay, what's happening is that we need to tell Padre what the word red means. And that's in the special file called colors.inc. So what you do is you tell Padre at the beginning, number sign include, and then in quotes, colors, .inc. That file contains the definitions of the various colors like red, blue, and so forth. Now if we click on run, that error should go away. Let's see what happens. Oops, I didn't spell include right. Include, I-N-C-L-U-D-E. Now try it. Aha! At least we didn't get an error, but it's still black. Now the reason it's black is we haven't told Padre where the camera is, and we haven't given it a light source. Before we can put a camera and a light source in, we need to understand the coordinate system that Padre uses. Now if that third number Z is 0, we can think of it as a piece of graph paper with the X going left and right, that's the first number, and the Y going up and down, that's the second number. When we said the sphere is located at the origin, or 0, 0, 0, that's like saying the center is at 0, 0 on the XY plane, and we also told it it has a radius of 2, so a cross-section of the sphere would look like this. Now there's a third axis called the Z-axis. That goes in and out of the screen. Positive values of Z are behind the graph paper, and negative values in front of the graph paper. So we want to put the camera somewhere in front of the graph paper, say -5 units in front, like this. We also want to put a light source in our picture. Let's say we put it 4 units to the right, 6 up, and then 10 units out. So first let's put the camera in. You type the word camera. And again, opening set bracket and closing set bracket. And then in between the properties of the camera, we have to tell it where the camera is. So that's location. And we decided that it's right in the center, but 5 units in front of the graph paper. So 0, 0, -5. And you also have to tell it what to look at. So look underline at, and we would like it to look right at the center of the screen. So look at 0, 0, 0. So that's how we put the camera in. Let me bring this up a little. And we need to put in a light source. And the way you do that is light, underline source, open set bracket, close set bracket. And in between, we have to tell it where the light source is. Let's see, we decided probably 4 to the right, 6 up, and 10 units back. And we also have to tell it what color the light is, and we'll say white. Let's see how this works. Aha! Now we can see our sphere. We have a black background. The sphere is kind of dim. The ball is a little bit dim. A way to brighten it up is to give it a finish. Finish. And say ambient. Ambient adds a certain amount of light to it. It takes a number between 0 and 1. 0 adds no additional light, and 1 makes it completely bright. So I usually use a value less than 0.5. Let's say ambient 0.4. Let's run it again to see how this looks. Much better. It's a bright, bright sphere. Now, another thing we can do is change that background from black to some other color. That's very easy to do. Let's put it after the light source. You type background. Oops, I spell it right, background. Open set brackets, let's call it gray. Oops. And let's see how this looks. Okay, so you can make the background whatever color you want it to be. I'd like to move the camera back a little more. Let me move it back to -10 instead of -5 because we're going to do some other things with this. Okay, same ball, but the camera's been moved back. Now there's a better background that's kind of a dull, uniform color. Let's take out the background here and we're going to do something else. There's what's called a sky sphere. It goes like this. Sky, underline sphere. And again, opening bracket and closing bracket. What we can do is we can put a gradient in there. So let's see, pigment. Pigment needs an opening and closing bracket, so let me do those first. And what we can say is gradient. Now I want the gradient to go up and down in the y direction. I'm going to make it like a sky that's sort of whitish at the horizon and blue way up. So what you do is, with the gradient, you put what's called a color map. Color underline map. And that also needs an opening and closing set bracket. So we'll put those in. And we're going to use two colors. Here's how you do it. You put a square bracket. You use numbers from 0 to 1. At 0, we want the color white. And at 1, we want the color blue. I'm not sure if you need to write the word color there. I'm using the wrong closing bracket. It's a square bracket there. Like that. Now what this does is a color map with a gradient starts at the 0 color and then it gradually goes up to the 1 color. And let's take a look and see what this is like. Very interesting. Now these numbers are from 0 to 1, so apparently it's in the middle of the screen. So 1 is at the top, 0 is at the bottom, except it's offset. So maybe if we move it down half a unit, we can get it to look more like a sky that we want. Now, a way you can move this color map down is right after, or the gradient, you can put what's called a translate, and you give it coordinates where you want to translate. You don't want to move it x-wise, but we want to move it half a unit in the y direction, so let's say negative 0.5, because I want it down in the y direction, and 0 in the z direction. So what that's going to do is it's going to move all of this, the gradient of the color map, down half a unit in the y direction. Let's see how this looks. Ah, that does look like a sky now. See, it's whitish at the bottom and blue at the top. Well, let's see what else we can do with this. Maybe we can make some more spheres. Let me copy that sphere. So highlight it. You can do Control-C to copy, or you can go to the Edit menu and copy. And then below it, you can do Control-V or go to Edit, Paste. And we have two copies of the same sphere, but let's move the first one left. Let's say that we move it left 2 units, and let's say we move the other one to the right 2 units. And now let me make it 4 units, and let's change its radius to 1, and let's change its color to blue. And see what's happening. So I've got the original sphere 2 units to the left instead of at the origin, and the other sphere 3 units to the right. Now let me make it 4 units to the right. 4 units to the right, and I made it blue. Whoa, I put blue in the wrong place. What happened? I lost the pigment. All right, let's copy the pigment over. Copy. Okay, paste pigment, and I want that to be blue. Let's see what this does. Ah, very interesting. So here's our blue sphere centered 4 units to the right, our red sphere centered 2 units to the left. Let's put one more sphere in there. Let's copy this last one. Control-C for copy. Control-V for paste. Let's change its color to yellow. Let's put that one right at the center and see how that looks. I've got a radius 1 in that. Notice how it sort of merges with the red sphere. What if I set its radius back to 2? Okay, you see what happens when they overlap, they kind of get squished together. They merge together. Well, that should give you an idea of how you set things up in Pavray. Well, that's it for this lesson. In lesson 2, we'll look a little more closely at the sky sphere, the colors that you can use, and how to translate things, and also how to scale things and make them look a little more interesting.
So please start overlay program in your computer by yourself. And according to the instructional video, please type by yourself and check your programs works well or not. Okay?
tulisannya harus kita sambung dulu kali.
Attention please. Now we will have a 10 minutes break. Start from now. So we will continue our expert sharing at we will continue the expert sharing at 10:35. Yes, at 10:35. Thank you.
About statement. Now in the lesson one, skysphere. Skysphere is used for making an image. Skysphere is used as a background. Skysphere is used to create a realistic sky background without the need of additional sphere to simulate the sky. For starting the next programs, please see the help. Push the help button and please see the statement and open the, please type in the sky spheres. I explain the sky spheres. Maybe a little bit long statement. This is explanation of another color creating method. Here, in this slide, text in the pigment, wood. Wood is, of course, please see this from this statement, color maps, 0.0 color dark 10 and 0.9 color dark brown and 1.0 color very dark brown. So the color is changed gradually from 0.0 and 1.0 colors. And between 0.0 and 1.0, 1.9 color dark brown is inputted. So the color change from dark town to dark brown, and finally color becomes very dark brown. So if you want to change the color gradually from 0.0 to 1.0, you can input many types of colors between 0.0 and 1.0. Now you used from white to blue. So the color is changed from the coordinate 0 to 1. So please change to, yes, of course. The color is changed from coordinate 0. In this case, at the coordinate 0 is white, and coordinate 1, this is according to the y direction. At the coordinate 1 of the y direction is blue. So the color is changed from 0 to 1 gradually. So if you want to change from blue to white, you must translate the position So the starting point changed a little bit. So the center pictures translate 0, comma minus 0.5, comma 0. So the 0.5 is moved. 0.5 means minus direction and 0.5. The starting point is moved. And the light picture shows scale 2. Scale 2 means position is multiplied 2. So the starting point is changed from 0 to 1. In this case, 0 to 2. So the scale is enlarged. Okay, next one. Okay. In the first program, one statement, finish. Finish is, now it's, in this case, we use for the light from the around the object. The finish property of surface greatly affect its appearance. And this decides light reflect from the object, not to make a shadow of the object. And you use also use a translate statement. Translate means that only the direction, moving direction and moving distance. It is not absolute value. This is a relative value. So the in this picture, in this slide, sphere is located 10, 10, 10, and translate statement -5, 2, and 1. So the sphere object moved 5, 8, 5, 12, and 11. Okay, so let's try to object according to the lesson 2 video. So please show the lesson 2 video.
Some more interesting details. In this lesson, I'm going to show you some of the things I skipped over, and we'll look a little more closely at the sky sphere, which I didn't do a very good job of. And then I want to show you the 3 types of transformations that you can use on objects in Power. Okay, here is the lesson 1 that we did before. I want to look at a couple of details. First detail is this part right here, the 320 by 240 AA03. You can actually change these things. Let me leave it there, and we'll run the program once again. And there's our window with our scene from the first lesson. Another thing you might notice is as you move the cursor around that window, you get different numbers at the top. These numbers represent the pixel positions. 0, 0 is the upper left-hand corner, and if you go down to the right-hand corner, it should get close to what we have it set for, which is 320 by 240. I can't quite get there. You can change the size of that window by changing this. For example, 512 by 384. And then if we run it, we get a bigger window. So you can make those windows almost as big as you want, as big as the screen or even bigger, which is what you would probably do if you've got a scene that you really like and you want a good copy of the picture. The disadvantage of making the window large is that it takes a lot longer to run, and if you have a complicated scene, it could take a very long time. So I usually keep it set at 320 by 240, and always use AA03. That gives you a higher quality picture. I'm not sure what the AA is for, but that's one of the details I wanted to show you. We are going to take some of the instructions that we wrote in the first lesson and use them again for this lesson. So let's start with the include colors.inc. That's a special file that Pavare refers to if you want to use names of colors, such as red, green, blue, and so forth. Highlight it and then copy it. You could do Control-C, or I'm going to use the editor. Now let's create a new file here, a new text file, and go to Edit Paste so that we get that include in our new file. Now I also want to take the camera and the light source and the sky sphere from the first lesson, so scroll down to that, drag the mouse across it to highlight it, and then copy that and go to the new lesson and paste it. And now we have a file that tells Pavare to put in the camera and the light source and the sky sphere. So if we run this, all we're going to see is that sky sphere, which I translated down half a unit. Oh, if I click on run, it asks me to name the file. So let's call this one less2 for lesson 2. Click on save and then it should run it. And there it is. There's our sky sphere as we have it. Now the problem with this sky sphere is I hastily said, well, we can move the whole thing down. Let's look in more detail at what's actually happening here. What's going on with the sky sphere is we have a color map. Before I translated it, we got that blue ridge there. So here's our sky sphere, and then it gradually went up from white to blue at the top. Now, my thinking was that I could translate that down half a unit. That means this whole gradient thing, because it repeats itself over and over again. And the effect of translating it down would be this. So if we're looking at the center and we don't look too high in the sky, then we're going to see it gradually go from a sort of a light blue to a dark blue at the top. But the problem is if we change the camera angle and we start looking down more, we're going to see this blue band here, or we're going to see a white band here. Now, the better way to do this would be to scale that whole gradient. And scale 2 tells Pavare to make, and I did it with the gradient, tells it to make it twice as large. And so if we try it like that, we should still see a blue band, but not quite as much white up there. Let's pull Pavare back and see what happens if I do that. Let me take out this translate. By the way, a way you could take the translate out without really erasing it is put 2 slashes in front of it. That tells Pavare to ignore anything after the 2 slashes. It's a handy way to remove things that you temporarily want to remove. And by the way, before I do anything else with this, let me run it to see if I get what I had before. Yes, I do. See, you get that dark line there, and then it starts going up to blue. Now, what I want to try is, instead of translating it, I want to scale it. Scale 2, so I'm scaling that gradient. Let's go down a little bit instead of translating it. And if I run it, I should still see a blue band. Yes, I do, but you see it's not, doesn't get blue as fast as you go upwards on there. Now I should do a translation. So I could translate it either up or down. Let me see if, I scaled it. Now what I'd like to do is I could move this whole thing up. What would that be? That would be 1 unit. So if I translated the whole thing up 1 unit, then I should get something like this. So it would be white at the very bottom and deepest blue at the very top. So let's follow that scale too by translate 1 up. We're translating this gradient thing up 1 unit. Let's try that with Pavre and see if that does the job. So let me remove these brackets for translate. I don't want negative 0.5, I want 1 up. And by the way, I could do 1 down just as well. I'm sure that would work. Let's take a look and see how this looks. Aha! You see, there's our sky sphere. Now we won't run into problems if we change the angle of the camera. If we make the camera look way up, for example, we should see a dark blue. A way we could do that, to look up, is we could make the y a big number. So look at, say, 100 in the y direction. And yes, you see, we see a dark blue. And if we look down a little bit, like maybe I go down negative, let's not go 100, let's go down negative 10. If I look down, I should see a whitish. Yes, I do. You see that? So that kind of takes care of the problem. And that's probably the best way to do the sky sphere there. We could use slightly different colors. Pavre has a whole help file. If you go to the help file and comes up with contents, and you also have an index which you can use to in lesson 1, so look at, say, 100 in the y direction. And yes, you see, we see a dark blue. And if we look down a little bit, like maybe I go down negative, let's not go 100, let's go down negative 10. If I look down, I should see a whitish. Yes, I do. You see that? So that kind of takes care of the problem. And that's probably the best way to do the sky sphere there. We could use slightly different colors. Pavre has a whole help file. If you go to the help file and comes up with contents, and you also have an index which you can use to search for things you know the names of. Let me go to the Pavre reference. We're talking about an include file. There is include files here. I open that up. Colors include. I think that's what I'd like to know. Predefined colors. And that's very interesting. So you get a whole chart there that shows the different colors. See, here, red looks like this, green looks like this, blue looks like that, you've got magenta, you've got cyan. If you scroll through that, there are lots of different colors that you can use. They even have a dark slate blue. We might try that for the sky. Dark turquoise. I think there's some sky blues in there. Medium blue, midnight blue, interesting, navy blue. So if you don't like the color of the blue, there's a sky blue. I don't know about that. The colors are above this. But help menu gives you lots of information. Feel free to use that. I'm going to show you a little more about that translate and scale, plus another one called rotate. Let's first change this negative 10 back to 0 as far as the look at where the camera is concerned. And let's go back to lesson 1 and copy one of those spheres. Let's say the first sphere there. Copy it, and we're going to put it into this new lesson. Let's put it down at the bottom. What's a good place? Right here. Paste it. Okay, I put in a sphere of radius 2, and the center is at x equals negative 2, color red, so forth. Let's run it to see what we have. Automatically save. Okay, it's 2 units to the left and it's radius 2. Let me change that to a sphere right at the center and make the radius 1, because I want to play around with it and show you some other things. Okay, there it is, it has radius 1. Now, what I could do is I could take that sphere of radius 1 and I could scale it by 2, and that will give you the same result as if you had made the radius 2. Another thing I could do is I could translate it to the right 2 units, and it has radius 2 and it's translated to the right. So that's what scale and translate do. You can do something more interesting with scale. You can actually scale the x, y, and z parts of it separately. So if you give 3 numbers in angled brackets like this, say I scale it 2 in the x direction, but only 1 in the y and z directions, and by the way, you never scale an amount of 0, because that'll make it disappear. This gives you something very interesting right there. See? Another thing you can do, before I translate it, but after I scale it, I can rotate it. Rotate the scaled object. Rotate takes 3 numbers too. The first number is an angle in degrees about the x-axis. That wouldn't be very interesting. Second number is about the y-axis. The third number is interesting in this case. That's about the z-axis, which points in and out of the screen. So I'm going to rotate through 45 degrees of the z-axis and then translate it to units. Watch this. See that? Really cool. Well, that's all I'm going to do in this particular lesson. In the next lesson, we will look at other kinds of objects that you can make in pottery.
Okay, thank you. So please make a program according to the video by yourself, okay? Let's start. Okay. We would like to go to a next step. Populate has other basic shapes except sphere. The basic shapes: box and cone, cylinder, plane, and torus. So I will show these objects. Okay. Next one. Okay. The box is one of the most common objects. We try this example in place of spheres. In the example, we can see that the box is defined by the specifying the 3D coordinate of the opposite cornea. You can see the left and lower position, and the right and the high position of cornea 2. Two position, cornea 1 and cornea 2, is decided by giving a coordinate position, coordinate point. Next one, please. Yes. And this is one of the examples. Here is a box statement. First point is near lower left corner, -1, 0, -1. And the next one is far upper right corner. At this position, 1, 0.5, 3. So giving the 2 corneas, box is decided. Here, next one, very interesting, another statement, textures. Textures are the pattern of object and color also included. Here, text T underbar stone 25. This is one of the a texture over stones. And here, scale 4. This is scale 4 is scaled by the same amount in all directions. And next one, next basic object is cone. Here is another example of a cone. The cone shape is defined by the center position and radius. Cone are B1, B2, B3, and large R. This is a coordinate of bottom circles. Center position is B1 and B2 and B3. Large R is a radius of the circle. And next one, C1, C2, C3, 3 numbers decide the position of the upper circles. And next one, small r also decides the radius of these circles. If the radius r, you can choose of course 0. So this is an example in the program. First 3 numbers 0, 1, 0. This is a position of the bottom position of the circle, and 0.3. this is the radius of the bottom circles. And second three numbers, 1, 2, 3. This is the position of the another circle, center of the another circles. Okay. If you choose open statement, so the inside of the cone is blank. And next one is cylinder. Cylinder also decided by the position of the bottom circle and the top circles. In this case, radius of the circle is same, so just only one number of small r is given. So this is one of the example of cylinder statement. In this case, it's open statement is used. Open means inside of the circle is nothing. And one more is plain object. Next one, please. Okay. Okay. Plane is very easily decided. Plane 0, 1, 0, three numbers shows the position of plane. And also, sorry, please show, please look this one. Next, the last one, plane y, comma 4. This y, comma 4. Please see this one. Okay, this is an example of plane. This statement, please see here, y minus 1. Y is a direction of normal direction to the y-axis. So this plane is in x and z planes. And minus 1 means from the origin of y-axis. So plane y comma minus 1 is shown in these figures. The last one is torus. Torus is a donut. Torus is easily decided by using two radius. One is a major radius, and the other is a minor radius, as shown in these figures. So this is example of a program statement. Yeah, torus 1 and 4. This is a big circle. The radius of big circle is 4, and the minor circle is 1. After making a torus, this torus is rotated according to the x-axis, just minus 90 degrees. Okay, so please try to make the object according to my PDF text, please try to make a box and cone and cylinder and plane and torus. Please make by yourself. Please try. Okay.
There is a better camera that we could use. Let me show you that. The camera that we're using, the default camera, is somewhat of a wide-angle camera. What you can do is add angle so that we can see what it is really like. Let's see, if I rotate it about the x-axis, I think I want to rotate it negative 30 degrees or some negative angle about the x-axis. Let me give that a try. And maybe we can get a better idea of what the cylinder looks like. Ah, yes. So here's the cylinder. object, nice solid object, has a top to it. One more thing about the cylinder, to make it more interesting, is after you've specified its location, you can say open, and let me show you what that does. See, it opens it up so you can see the inside of the cylinder, so like it's a can without a lid on it. But that's basically how you do a cylinder object. Okay, let's do another object. Let's do a box. Let me move that cylinder over, maybe a few units to the right. Let's do a translate. Oh, what's a good position for it? Let's go 3 to the right, 300. Let me make sure that doesn't mess anything up, so that I have room to put a box in here. Aha, that looks pretty good. Okay, so we're going to do another one now, and that's going to be a box. But to know how to set up a box, again, we'll go to the help menu and type in the keyword box. And that tells you how to do it. You specify corner 1 and corner 2. Once again, let me show you a better diagram for that. As you can see, a box is specified by locating 2 corners on a long diagonal of the box. It's done like this. So let's see, we can start here and put in box, put in our set brackets, and the closing set bracket with a comment after it that says end of box. And then in between, we have to specify the 2 corners. So let's see, we have to make a decision. Say the left corner. Not sure what size I want it. Let's go -1 on X. We'll try to keep it in the center. Let's go -2 for Y, and I think Z should be the same as X. I'm just guessing at this. Let's see. And 1, 2, 1. So I've got a left corner and a right corner. The left corner kind of sticks out on the Z. I need to give it a pigment and a finish, so let's copy that from the cylinder that we did. Copy that and put that in our box. So we're going to have a red box. Let's see what it looks like. It's running into the cylinder. I didn't give much thought to its location. I know what we can do. Let's move it left a little bit. We could move the cylinder more right, but there's not a lot of room. Let's translate, let's say -2 in the X direction. And maybe we can see it better. Oh, I can't spell translate. Let's see, translate. There we go. There's our box. Again, it's a little bit hard to see what's happening with this box. Let's rotate it. Maybe -30 degrees with respect to X. See how it looks that way. Oh yeah, I can see what's happening. Let's rotate it with respect to Y a little bit. Let's say 20 degrees positive. We'll see what happens. All right, see, you can see that's how you create a box. I specified the lower left corner and the upper right corner, which is in back there. I think I have that backwards the way I'm talking about it. But that's how you create a box. Now let's do a cone. Let me take that box out and let me take the cylinder out. Let's highlight that and take that cylinder out. I'm getting too cluttered here in my picture. Okay, to see how to do a cone, again we go to the help menu and type in the index word cone, and keyword for cone, let's see. And the cone has a base point, a base radius, a cap point, a cap radius, and then write a little diagram there. Let me show you the diagram a little more clearly here. So a cone is sort of like a cylinder, except there are two radii. Again, you have a base point and you have a cap point, and you specify the radius of the base and the radius of the cap. If you make the radius of the cap equal to 0, you have a true cone. If you make it anything else, any positive number, you actually have what's called the frustum of a cone. So let's put in our cone. Cone, set bracket, end set bracket, comment, end of cone. And let's see, we need the base point. So let's put that 2 down. Y is -2. And we need the base radius. Let's give it a radius of 3. Oh, I didn't put a comma there. I think I need it. Radius of 3. And we need the cap point. So 0, +2, 2 up. 0. And let's give that a radius of 1. And again, we need to give it a color. So let's go up and... Oh, I didn't copy the color. I should have copied that before, but I have it from lesson 2. I can copy that. Copy it and put that in. And let's run it and see what we get. Okay. Again, I'd like to rotate it so that I can see better what's going on here. So let's rotate it by about the x-axis. Rotate -30 about the x-axis and see what it looks like. Okay, so there's our cone. Actually, it's a frustum of a cone. Let's see, if I change the top radius to 0, I should get a true cone. And there we have it. So that's how we make a cone. All right, one more object. Shall we keep the cone? Let's move the cone to the left. Translate. Oh, let's say -3 to the left. Let me make sure that works okay. Alrighty. And we're going to make another object. Let me move that cone down a little bit too, just so I have a lot of room. 1 down. In fact, let me change the color of the cone. I'm going to make it a green cone. See how that looks. Oh, really cool. Okay, so that I have room for one more object. So we are going to do what's called a torus. A torus is like a donut. Again, we go to the help file and type in the keyword torus. And let's see what that looks like. Okay, a torus only has 2 things, a major axis and a minor axis. Let me show you what the torus actually looks like and what this means. So a torus is always centered at the origin. Of course, you can translate it and move it wherever you want. You could resize it and do other things with it too. The torus is specified by its major radius and a minor radius. The minor radius is the radius of the round part of, well, the donut part is, I don't know, how can you say that? A slice of the donut. And the major radius tells you where the overall donut lies. I think the best thing to do is to just try it out. So we put in the keyword torus, and again, the set brackets. End of torus. And it requires two numbers. The first is the major radius, that's a bigger number than the minor radius. Let's give it a major radius of 4 and a minor radius of 1. And then we've got to give it a color and a finish, so let's copy that from above. Copy it from what we did for the previous object. And let's see, the cone. Let's change the color back to red, so the torus doesn't look like the cone. And let's see what we get. Aha, it's kind of bumping into the cone. Let's rotate it a little. Rotate like we did with the other things, let's say -30 with respect to the x-axis. And let's move it up. How far up should we do? 2 in the y direction. And then maybe we can see it better. Aha! There it is. So a torus is a donut. That minor radius is the radius this way. And the major radius is from the center to the middle of the ring around the torus. But that's what a torus looks like. Well, let's call it quits for this lesson. In the next lesson, I want to show you some of the things that you can do, how you can put a picture on an object, and that sort of stuff.
Okay, please start populate programs and using a mouse. No. Yes. Now, attention mark is put the last please stay here, mouse point the end of the program, okay? And, insert. So, and using a mouse, please please push the button of insert. Okay, please push the button of insert, and you can see many. Ooh. Okay, and please choose the basic shapes. Okay, so you can now you study. Okay, like that. Oh, so please choose cylinder Y. Okay, please push a button. Okay, so here cylinder is decided like that. This is an example, so you can choose directly each object. In a lesson 3, you decide the point 1 and 2 and radius and pigment. and maybe another properties can be decided. Normal. Normal is a direction. And the finish. Tone, deflection, metallic. These are default value. So if you cannot decide these values, program works. Okay, and please push a button to the file. Okay, file. No. Yes, and please push the, on open file. Okay, so you can see many folders. Advanced, animation, camera, gamma, like that. Maybe, so please push a button, the overlay, version 3.57, scenes. Now is these folders under the scene folders. So go to, no. Version. Yes. In the upper folder, you can see a folder of include. So please push the button, include files. Okay, please open the include file. Okay. So please push, okay, colors. Yes, okay. So in the include file, already many colors are decided. Declare is also this, starting from the large letters. For example, red. Red means RGB using numerically decided 100. So already decided red is RGB 100. So you can use directly call just only the name of red. And the color is decided by using this statement, declare statement 100. So this means a red. So please open another include file. Yes. Maybe. No. Open file. For example, a stone. Maybe stone. Yes. Yes, stones. Oh. Please choose stone 1. Yeah. So please see this statement. Declare T underbar GRNTO decided like that. So the color pattern is already decided. So just only call the name of T underbar GRNTO. This pattern is called from the include file. Okay. So just a minute for finishing the lesson 2. So we have a rest and take lunch. So until 1 o'clock. So see you again.
Oke ya. Jadi habis ini kita ada istirahat jam 1 sampai jam 1. Nanti jam 1 bisa kumpul lagi ke sini. Terus panitia hanya menyediakan snack. Jadi kalau yang mau makan siang bisa makan siang sendiri. Makasih.
Sekian liputan hari ini, saya Nasenjaka melaporkan dari Ukrida TV.